SiC means power chips for electric vehicles, and right now it means oversupply and falling prices. A piece of news just came out that shifts that assumption sideways. The 300mm SiC substrate Coherent announced for AI chips is not just a new product. I see it as a move to escape a price war of attrition. Today, I'll unpack what's really behind it. Hello everyone, I'm Ty, with 31 years in the semiconductor industry. Today, we're looking at Coherent's announcement of a 300mm high-thermal-conductivity SiC substrate for AI chips. By the end of this video, you'll understand why heat dissipation materials are suddenly getting this much attention, and what Coherent is really aiming at beyond this single wafer. You'll come away with a clear map of the strategy. Let's get started. As always, let me start with something closer to home. Picture a bedroom in midsummer. People give off a surprising amount of heat while they sleep, and if that heat has nowhere to go, you wake up again and again through the night. The key to sleeping well isn't chilling the room, it's letting the heat trapped against your body escape quickly. Lately, though, this town has gained some unusual residents. Their metabolism runs incredibly hot, several times that of an ordinary person. They work flat out, mind and body, and they earn on a completely different scale. But the heat they throw off at night is fierce. On a conventional mattress, that heat just builds up, and all that ability gets wasted on sleepless nights. You can reach for an ice pillow or turn the fan up. There are plenty of stopgaps, but the root problem is the mattress right underneath the body storing heat. Until that changes, blowing air from around the edges barely helps. So the real battleground is this: how fast can you pull heat away at the point closest to the body? Enter a mattress topper made from a special material that moves heat away fast. It feels cool the moment you touch it, and it keeps channeling trapped heat downward. Better still, it comes in standard bed sizes. You don't have to replace your bed or your bedding. You just lay this one sheet down, and you're done. That ease of adoption is part of the pitch. The maker of this topper is a group of craftspeople who handle everything in-house, from the raw fiber through weaving to final inspection. And what they're aiming at isn't a price war over toppers. It's to work their way into the design of the whole bedroom, pillows and air conditioning included, until they're indispensable. Now, let me show you how this plays out in the real industry. Coherent, the company at the center of this, is an American optics and materials firm known for lasers and optical communication components. It has also made SiC substrates for years. SiC, silicon carbide, is a hard material that stands up to heat. On August 17th, US time, Coherent announced a new substrate for AI chips, and the industry took notice. Here's what was announced. Coherent has begun sampling its 300mm high-thermal-conductivity SiC substrate to key AI semiconductor partners, meaning customer evaluation has started. The substrate is intended as a heat-spreading material that pulls heat away from AI chips and high-performance computing systems. Coherent says it is designed to improve thermal spreading performance by up to 25% versus current solutions. There are caveats. The release doesn't spell out what that 25% is being compared against. How much the temperature actually drops in a real system is something customer evaluation still has to establish. What the announcement does state clearly is that the substrate is designed to stay compatible with existing manufacturing platforms. That compatibility point is worth holding on to. On the operational side, Coherent is vertically integrated. It handles SiC crystal growth, wafer processing, polishing, and evaluation entirely in-house. And moving to 300mm looks aimed at matching the wafer size that is standard on semiconductor volume production lines, so customers can run it on the manufacturing infrastructure they already have without rebuilding the line. Now to the heart of it. Most of the attention is going to that 25% figure, but what I find interesting is the application. In this industry, SiC has always meant a substrate you build power chips on, for electric vehicles and the like. Here, SiC isn't the foundation you build a chip on, it's a plate for moving heat. That's the big point. Behind this lies a harsh reality in the SiC market. Suppliers race to expand capacity, and the result has been oversupply and falling prices. The SiC substrate market is reported to have shrunk 9% in 2024. As long as you keep fighting on price per wafer, you can't escape a war of attrition. That's exactly why finding a completely new use for the same material matters so much. Meanwhile, on the receiving end, AI chips are throwing off enormous amounts of heat as the performance race accelerates. It's no exaggeration to say that whether a chip can deliver its full capability comes down to how you get the heat out. The idea here is to put SiC's high-thermal conductivity to work on that job. It's exactly the cooling topper from our story. And in my reading, Coherent's real target lies further out. Beyond SiC, the company has a broad portfolio of optical device technology, indium phosphide lasers, silicon photonics, CPO. When optical electrical integration, bundling light and electricity into a single package, becomes mainstream, Coherent wants to be embedded deep inside customers' designs as part of the thermal design itself. That, I believe, is the real aim. Of course, there are hurdles. Customer evaluation has only just begun, and adoption depends on how the AI chip side designs its systems. The real-world strength of that 25% figure has yet to be verified, and design-in, getting built into a customer's design, is a long war that can take years to show results. Even so, this shift in direction matters. A price war over dollars per wafer is exactly the ground Chinese suppliers, still adding capacity, are good at. Coherent is stepping off that ground and moving the axis of competition to systems, where it proposes optics, thermal, and materials together. Once you're inside a design, you're not easily replaced. It's a shrewd move, defensive and offensive at once. Let me also think about what this means for Japan. Japan has companies in SiC materials and related components, and the same wave of oversupply and falling prices is hitting them. The contest is shifting from how cheaply you can sell a single part to how deeply you can get into a customer's design. Coherent's move here is a useful example for Japanese materials makers facing the same problem. The decisive question in materials is moving from what can you make and how cheaply to whose design are you built into and where. Simply being able to make something technically difficult isn't enough to win anymore. Where you sit in the customer's value chain decides it. This news is one wafer that symbolizes that larger shift. At least, that's how it looks to me. To sum up, Coherent has started customer evaluation of a 300mm high-thermal conductivity SiC substrate for AI chips. Thermal spreading is said to improve by up to 25%, but that still has to be proven. And the real aim is to become a platform, embedded in customers' designs along with the thermal design itself in the era of optical electrical integration. That's how I read it. That's all for today. I'll keep bringing you semiconductor news and analysis, so if you found this useful, please like, subscribe, and I'll see you in the next video. This has been Ty on Semiconductor News Decoded.